For question number 13a, we need to find a quadratic equation with the roots that are given. So for a, we have the roots of root 7 and negative root 7. Now, if we can recognize that that is really just plus minus the square root of plus minus 7, then we can use that equation to work that out, and we can just work out our quadratic equation as that. Now, the other strategy is to write it in its factored form. So we can write this as x minus root 7 as one root, x plus root 7 as the other root, make it equal to 0, and then just expand these brackets. Because this is a difference of squares form, we're going to end up with x squared minus root 7 squared equals 0. So that's A. So we can just kind of guess what the quadratic equation, since it's going to be plus minus, or we can put it into this factored form. For B, we're going to start with this factored form, okay, and see if we can write the quadratic equation using the factored form. So if I have a root at 1 plus root 3, it's going to be x minus 1 plus root 3 as my root. And the other root is going to be x minus 1 minus root 3, and that's the factored form equal to 0 that gave me the solution. To come up with the quadratic equation, I can expand this out, x squared minus, and because these are both minus, they're going to just add together, so I'm going to end up with 1 plus root 3 coefficient plus 1 minus root 3 coefficient, and that's going to be the coefficient on x, plus, so negative times negative, so I'm going to end up with 1 plus root 3 times 1 minus root 3. That's a difference of squares. That's all equal to 0, and I could just simplify this expression. So I get x squared, the plus root 3 and the minus root 3 cancel out in the coefficient. So I end up with 1 plus 1, that's 2, and then my variable is x. This constant term, if I expand this out, I get 1 squared minus root 3 squared, which is 3. And then just combine those like terms, I end up with x squared minus 2x minus 2 equals 0. Okay, so what I've done is I've taken those two roots, these two roots here, and I've put it in the bracket form, made it equal to 0, and then just expanded out those brackets. Now, another strategy for the same question could be that we can use the quadratic formula form. So we know that x is equal to 1 plus minus root 3 over 1. Okay, and this is going to be in the negative b plus minus the square root of b squared minus 4ac over 2a form. So we're going to try to match this up. So we're just going to let a equal 1, and if a equals 1, we know that the denominator is equal to 2, so I just need to make sure I get a factor of 2 in the denominator. So I'm going to times the bottom by 2 times the top by 2. And by doing that, we're going to equate the parts here. So I end up with x is equal to 2 plus minus root 2 root 3, which I'm going to put the 2 inside, over 2. And as I match my coefficients here, that 2 here, this negative b and 2 must match. So then I get b is equal to negative 2. Okay, so if I put negative of negative 2, I get the positive 2 there. And so that comes from matching that b in the quadratic formula. Now, if that b, I'm just going to rewrite this here, this is equivalent to x equals 2 plus minus square root 12 over 2. Now I'm going to match the inside part of that. So this needs to match the 12 here. And we already know what b and a are. So I'm just going to rewrite this as b squared, so negative 2 squared, minus 4 times 1 times c, and that's going to be equal to 12. Okay, so what I've done is I've taken the inside, b squared minus 4ac, and made it equal to 12. So there it is, b squared minus 4ac equals to 12, and I can then solve for the value of c algebraically. So 4 minus 4c is equal to 12, so negative 4c equals 8, divide, I get c equals negative 2. So now I've solved for the same coefficients, a equals 1, b equals negative 2, and c equals negative 2 as well. So that would be an alternative method. So depending on whether you want to expand all that out, you can do that. This one's maybe a little bit harder. It is essentially trying to solve a puzzle and matching parts of that puzzle. So I did this by making the assumption a equals 1, tried to make this form look like the quadratic formula form, and then tried to match up the parts. In this case, I was able to match up b and the 2 here to get the negative 2, and then I matched up the inside, the discriminant part of this, and made that equal.